Something remarkable is happening across the United States right now, and it's catching a lot of people off guard. We're dealing with a cold wave that's not just severe, but genuinely extraordinary in its reach and persistence. When you have parts of Florida experiencing temperatures colder than some areas of Canada, you know the atmosphere has taken an unusual turn. This isn't the kind of temperature inversion we see occasionally during winter. This represents a fundamental disruption in the typical flow patterns that govern our weather, creating a situation where subtropical regions are experiencing conditions more commonly associated with much higher latitudes. The implications of this temperature flip extend far beyond just being an interesting weather curiosity. Agricultural interests across the normally mild Gulf Coast states are scrambling to protect sensitive crops and livestock. Infrastructure that was not designed for sustained freezing conditions is being tested in ways that reveal vulnerabilities most people never considered. Water pipes are bursting in regions where such events are rare enough that many homes lack adequate insulation or protection systems. What makes this situation particularly striking is how locked in this pattern has become. For weeks now, we've had this cold air trough sitting over the eastern United States like it's decided to make itself at home. The jet stream structure has created what meteorologists call a persistent pattern, where Arctic air just keeps flowing southward with remarkable consistency. It's not the typical quick shot of cold that moves through and moves on. Instead, this has been a sustained push of frigid air that's affecting regions not accustomed to this level of cold. This persistence is rooted in what atmospheric scientists refer to as a blocking pattern. High-pressure systems have positioned themselves in such a way that their essentially steering wheel for our weather has gotten stuck in one position. The normal west to east flow that characterizes much of our weather has been replaced by a more meridional flow, where air masses move in pronounced north-south trajectories. When these patterns establish themselves, they can maintain their grip on regional weather for extended periods, sometimes lasting weeks or even months. The energy dynamics behind this setup are fascinating from a meteorological standpoint. The temperature contrast between the frigid air mass and the relatively warmer air it is displacing creates significant atmospheric tension. This tension manifests in various ways, from the development of storm systems along the boundaries between air masses to the creation of conditions that can support unexpected weather phenomena. But here's where things get interesting and potentially more disruptive than many people realize. While everyone's focused on the bitter temperatures, there's what we might call a sneaky snowfall threat developing. This isn't your headline-grabbing blizzard scenario, but sometimes these quieter systems can catch us more off guard than the big storms we see coming from miles away. These smaller-scale events often fly under the radar of public attention, but they can create disproportionate impacts precisely because people aren't mentally prepared for them. The meteorological setup for this snow threat involves what forecasters call a clipper system. These fast-moving disturbances typically originate in the Canadian prairies and dive southeastward into the United States. What makes them particularly tricky is their speed and their tendency to rapidly organize as they encounter the temperature contrast present in our current pattern. They don't have the massive moisture content of coastal storms, but they can be remarkably efficient at producing snow over relatively short time periods. The snow threat is setting up along a line that stretches from parts of the Midwest through the Ohio Valley. What makes this particularly concerning is the timing and the element of surprise. When people aren't expecting significant snow, even modest amounts can create major disruptions, especially during peak travel times. Rush hour commutes could become challenging very quickly if this snow materializes as some of the guidance suggests. The challenge with timing is that these clipper systems often arrive during periods when people are least prepared. Unlike major storm systems that generate days of advance warning and widespread media coverage, these smaller events can organize and arrive with much shorter lead times. The snow can begin falling during morning or evening commute periods, when roads are busiest and when even small accumulations can create cascading delays throughout transportation networks. Road surface temperatures play a crucial role in how disruptive even light snowfall can become. With the sustained cold we've been experiencing, pavement temperatures are running well below freezing across much of the affected region. This means that any snow that falls will likely stick immediately, rather than melting on contact as might happen during more typical winter conditions. The combination of cold surfaces and surprise timing creates a scenario where even an inch of snow can transform normal travel into a challenging experience. Now, when we talk about snow amounts, we're generally looking at accumulations in that 1 to 2 inch range across much of the affected area. That might not sound like much, but here's the thing about winter weather that experienced forecasters always emphasize. It's often not the storms you prepare for that cause the most problems, it's the ones you underestimate. And in some localized areas, we could see accumulations reaching up to 4 inches, which would definitely qualify as disruptive. The variability in snow accumulation with these types of systems can be remarkable over relatively short distances. Factors like elevation, proximity to large bodies of water, and local topography can create significant differences in how much snow actually falls from place to place. Areas that are just a few miles apart might experience dramatically different impacts, with some locations seeing barely a dusting, while others deal with several inches of accumulation. Elevation effects become particularly important in regions like the Ohio Valley, where even modest changes in altitude can mean the difference between rain, freezing rain, and snow. The Appalachian foothills often act as a natural snowmaking machine during these events, wringing additional moisture from passing systems and creating localized areas of enhanced accumulation. These terrain effects can catch even experienced local residents off guard, as familiar travel routes suddenly become much more challenging than expected. The challenge with these types of systems is that they can be deceptively impactful. People might look at a forecast calling for an inch or two of snow and think it's not worth worrying about. But when that snow falls during the wrong time of day, or when road surfaces are particularly cold, or when it's combined with gusty winds, even small amounts can create hazardous conditions very quickly. Wind becomes a multiplying factor in the impact equation. Even modest winds can create blowing and drifting snow conditions that reduce visibility and create uneven accumulation patterns on roadways. What might be a manageable inch of snow in calm conditions can become a significant driving hazard when combined with wind gusts that create whiteout conditions and deposit snow unevenly across travel surfaces. Looking ahead, the pattern doesn't appear ready to give us much relief just yet. As we move deeper into February, there are signals pointing toward another potential surge of Arctic air for the eastern United States. This could arrive around the 7th of the month, and early indications suggest it might represent the peak intensity of this overall cold pattern we've been experiencing. This potential February surge has meteorologists paying close attention to developments in the Arctic regions. The source region for this possible cold outbreak is currently experiencing some of the most intense cold of the winter season. When air masses spend extended time in these polar regions, they become increasingly modified, taking on characteristics that can produce truly exceptional cold when they eventually move southward. The track and timing of this potential outbreak will depend heavily on the position and strength of steering systems in the upper atmosphere. Slight changes in these factors can mean the difference between a glancing blow and a direct hit from the coldest air. The models are showing reasonable agreement on the general time frame, but the specific details of intensity and geographic focus remain uncertain at this range. What is particularly interesting from a meteorological perspective is that we're starting to see hints of change in the medium-term forecast. The jet stream pattern that's been so persistent may finally begin to show some volatility as we approach the middle of February. This could mean temporary warming for some regions that have been locked in the cold, but it also opens the door for new approaches of cold air from different directions. The transition toward a more volatile pattern often begins subtly, with small perturbations in the flow that gradually amplify over time. These changes can be difficult to detect at first, but they represent the early stages of pattern breakdown that can eventually lead to significant shifts in regional weather characteristics. The challenge for forecasters is distinguishing between temporary fluctuations and the beginning of genuine pattern change. There's even some intriguing development in the longer range that could represent a significant shift in our weather story. Between the 15th and 21st of February, we're seeing the first signals that point away from snow and toward the possibility of thunderstorms, potentially even severe storms in some areas. It's still early to get too specific about this potential, but it represents a window that deserves careful monitoring as we get closer. This would mark a notable transition from the winter-dominated pattern we've been experiencing to something more characteristic of spring-like weather. The atmospheric setup that could support such development would require significant changes in the overall flow pattern, which makes sense given the signals we're seeing for increased volatility in the jet stream. The energy that's been locked up in maintaining our current pattern could eventually be released in the form of more active weather systems. For regions that have been struggling with the persistent cold, there is some encouraging news on the horizon. Areas from Texas through parts of the central United States are likely to see temperatures climb back above seasonal averages in the coming coming period. This warming trend will be particularly welcome in regions that have dealt with extended cold and the power grid challenges that can accompany such conditions. The recovery process from extended cold periods involves more than just temperature changes. Infrastructure that has been stressed by sustained freezing conditions needs time to stabilize. Power grids that have been operating under maximum demand for heating will benefit from reduced load requirements. Agricultural systems will begin the process of assessing damage and planning recovery strategies for the growing season ahead. We'll continue monitoring these evolving patterns closely, particularly as we move toward what could be some significant changes in the overall weather story for much of the country.